Good day, everyone. Today, we are going to discuss quadratic functions. Let us start by illustrating quadratic functions. For a quadratic function ax squared plus bx plus c equals 0 to be a quadratic function, we simply replace 0 by y or f of x to form the quadratic functions y equals ax squared plus bx plus c, or f of x equals ax squared plus bx plus c. A quadratic function is described by an equation in the following form: f of x equals ax squared plus bx plus c, where a is not equal to 0. Or it could also be y equals ax squared plus bx plus c equals 0. Ax squared here is the quadratic term, bx is the linear term, and c is the constant term. Now, for our examples, let us identify if the following are quadratic functions. If they are, write them in standard form and identify the values of a, b, and c. Let's have the first one. Y equals x squared minus 3x plus 5. Is it a quadratic function? The answer is yes. It is a quadratic function in standard form. The values of a is 1, b is negative 3, and c is 5. Example 2. F of x equals negative 3x plus 4x. Is this a quadratic function? The answer is yes. It is also a quadratic function in standard form. A is negative 3, b is 4, and c is 0. Now let us have the third example. Y minus 6 equals x squared. Is this a quadratic function? Yes, it is a quadratic function. The standard form is y equals x squared plus 6. This time, the value of a is 1, b is 0, and c is 6. For our fourth example, 3x squared plus y equals 3x squared plus 4x minus 2. Is this a quadratic function? No, this is not a quadratic function. Notice that when you simplify, the function will result to y equals 4x minus 2. The degree is no longer 2, that is why it is not a quadratic function. Now, how do you identify if it is a quadratic function using table of values? In a quadratic function y equals ax squared plus bx plus c, remember that equal differences in x produce equal second differences in y. Now let us tell whether the table of values represents a quadratic function. I have here a table of values where x is negative 1, y is 0, x is 0, y is negative 1, x is 1, y is 2, and so on. The first thing we have to do is to identify if there's equal differences in x. 0 minus negative 1 is 1. 1 minus 0 is 1. 2 minus 1 is 1. And 3 minus 2 is 1. Thus, there is equal differences in x. Now, let us have the first difference in y. Negative 1 minus 0 is negative 1. 2 minus negative 1 is 3. 9 minus 2 is 7. And 20 minus 9 is 11. Now, let us identify the second differences in y. 3 minus negative 1 is 4. 7 minus 3 is 4. 11 minus 7 is 4. What do you notice with the second differences? Notice that equal difference in x produce equal second differences in y. Thus, the table of values represents a quadratic function. How about if the second differences are not the same? Then it is not a quadratic function. Now, let us identify if it is a quadratic function using graph. Remember, a table and a graph can both be used to show solutions to a quadratic function. A quadratic function has a U-shaped graph that is called a parabola. This parabola may either opens upward or downward. Now let us check which of the following graphs are graphs of a quadratic function. Is the first one a graph of a quadratic function? The answer is yes. It is actually a U-shaped graph that is a parabola. This parabola opens downward. How about the second one? Is this a graph of a quadratic function? The answer is no. It is not a U-shaped graph, but rather it is a straight line. This is a graph of a linear function and not a quadratic function. How about the third graph? Is this a quadratic function? Yes, it is a quadratic function. This is a parabola that opens upward. How about the fourth graph? Is this a graph of a quadratic function? The answer is no. This is a graph of a cubic function.